Good day, ladies and gentlemen. Once again, you're welcome to Okunlola Academy. I want to thank you for subscribing to our channel and liking our videos. We want you to please subscribe to this video as well, like and share it. Now, today we have come to take a topic titled Regression Analysis, the decision tree that you must take while running your time series analysis, as it were. So, by way of our regular outline, we have lined up three basic subtopics. We are going to look at briefly what regression analysis is. Then we'll talk about basic assumption, its basic assumption, and thereafter we'll go to decision tree that is made while running your time series regression analysis. Now, basically, a regression analysis is just a statistical process which is used to, estimate the relationship that subsists between one variable and another variable. And one variable may be called the dependent variable, while the other variable may be called the independent variable. The essence is just to determine whether a significant relationship or not exists between these variables, as the case may be. Now, in doing that, we say there are basic assumptions which should be fulfilled while trying to perform your regression analysis. One of them is that there is the existence of linear relationship between verified variables. In that sense, it means that there is the variables do not wander too far apart, whereby you have a nonlinear relationship, as it were. So it means that there must be a linear relationship subsisting between the variables. Now, two is that it is expected that the residues of the variables you are checking are not correlated or independent, as the case may be of each other. Likewise, it is expected that the residuals in the model have constant variance. The constant variance is to identify whether your variables will or are homoscedastic or they are not. Likewise, the residuals are also expected to be normally distributed. If you wish to get hands-on information, you may wish to check our videos that we did on normality distribution of variables. Now, going forward, this is the decision tree that we must follow while running our regression analysis, as the case may be. Now, looking at our graphical illustration, we'll see that this is the regression foundation, which is telling us to check to follow this route, the stationarity test or the unitary test, and these are the stationarity estimation techniques that can be adopted in checking our stationarity, as it were. Basically, for most time series data, it is expected that we subject them to stationarity test. The essence being that it is assumed that the process that generates the data you are using should not change over time. That's the reason why we need to subject such variables in order to be sure that they become stationary to perform further estimation. And in doing that, we either use the popular augmented decay-Fuller ADF and the decay-Fuller GLS and the Philippe-Piron NGPP and KPSS, as the case may be. Now, what the implication is that the ADF is just is an extension of the decay-Fuller test, decay-Fuller GLS test, in the sense that the ADF assumed to be more robust into more or large samples or time series data in our model. Likewise is also the Philippiron as it is, and it is also assumed that it is far more robust in dealing with larger data than the ADF as it were. And in doing that, the NGPP and KPSS, most importantly, the KPSS has an inverse of reporting the outcome that you generate from your stationarity test, as the case may be. Why ADF, GLS, and Philippirum, have somewhat similar preposition when you are stating the hypothesis, then the KPSS is inverse that proposition. Likewise, you may wish to combine either the ADF or the PP in your study in order to be sure that you have tested a robust time series. Having said that, we're going to dwell on the decision tree that you make while you run your ADF stationarity test as well. Then going further, we'll say that there are basically four outcomes that is visible when you run your ADF. Also recall that there are three parameters, but we are not going there, whether you are doing none, you are doing trend, or you are doing trend, and the three basic parameters actually, so that you can also use to perform your stationarity test. However, what we are concerned about is your turnout, your outcome in your estimation. Now, for basic outcome, we have the order 0 here, whereby your variable turns out to be stationary at order 0, that is at level. Your variable turns out to be false difference. Your variable turns out to be combination of order 0 and order 1, which means it turns out to be a mixed order of stationarity at 0 and high 1. Likewise, your variables can turn out to be high 0, high 1, and high 2. Now, basically, you may not want to go the route of high 2 variables, in the sense that you may wish to increase the number of variables in order to, to take care of the I2, or you may wish to also log your variables, or you may wish to go through the three routes of the trend and the non and the trend analysis of decay, polar, and as the case may be. Here you have basically three routes: the non, the trend, and the linear trend, as the case may be. So going forward, when you have your series, your time series, coming out to be I0, which means that your variables turns out to be I0, the decision you make going forward will just be to simply run your simple regression analysis as it were. Then you report your results. Now, if your variables turns out to be of I1 variables, that means they become stationary after you have false difference. It means that you're going to take a decision on whether to check for the co-integration. Rather, here you mean to check for their long run significant relationship in your study. And by the time you check for your co-integration result, you basically will be making decision based on trace statistics, which is eigenvalue, or you make your decision based on a maximum eigenvalue. When you compare the two, the outcome tells you whether there's a presence of co-integration or there's absence of co-integration in the model. Going forward, when there's absence of co-integration in the model, the next decision you make is to run the short run vector autoregressive distribution. Vector error. The vector autoregressive model, VAR, you run it here in essence to actually check the significance of the co-integration as it works. Likewise, when the co-integration tells you that there's presence of co-integration long-run relationship, you run what is known as the short and the long-run error correction mechanism. Likewise, when you go through the short and long-run error correction mechanism, you go through either checking for the individual or the joint test as it were. Now, if you go through the individual joint test, what happens is that you are testing the coefficient and checking whether the variables in the model are significant in their individual form. Likewise, it means that you are checking the speed of the speed of adjustment of variables in their individual form, and by so doing you perform mainly the error correction mechanism. Then thereafter you check the system equation, whereby you test the variables jointly for both the short and the long run estimate. Doing that, you go through the route of vector error correction mechanism. Here, you simply plug in the target variable of the coefficient of the long run variables in your system, and join and test them jointly to ascertain the level of to understand the speed of their adjustment to equilibrium, as the case may be. Likewise, you may also want to identify whether they conform to the basic rule of assumption, whereby the coefficient are expected to be negative and significant at the same time. Having said that, going through when your variables turns out to be of a mixed order, meaning that the variable turns out to be a mix of high zero and a mix of false difference, meaning that the combination of two will lead you to performing what is known as the ARDR model, which is the auto-regressive distributed lag model, as the case may be. Then going forward, when you have a mix of I0, I1, and I2, it is expected that you can undertake your grandeur causality estimation. However, recall that if you do not wish to go through the route of false difference, you either want to increase the number of your time series, or you simply want to log your variables, or you simply want to change the particular variable that's making you to have a mix of I2 in your study. Having said that, we hope we have been able, to give you an highlight of the decision that you take when you are running your regression analysis. However, this analysis sometimes they are not static, because it depends on the intention that you need to investigate in your study. However, this stationarity represent the pre-estimation analysis for most of your time series estimation in your study. We hope we have been able to shed light on this particular video. So thank you. Create your indulgence. So please subscribe to this channel, like, share. Thank you.